Hello there, algebra students. Welcome to Standard Form of an Equation, Section 5, Chapter 5, Section 5. Here, this will be our third equation that we're learning for linear equations here. And we'll look at it and see how to turn things into this form of an equation. And we will look at it and see why it's valuable for us. As all of the things that we've looked at so far have a purpose, like slope-intercept form has a purpose because you can quickly identify the slope and the y-intercept, which is a valuable piece of information. Point-slope form is valuable to us because if we have any point, we don't have to have the y-intercept. We can create the graph and an equation to represent that particular graph. So the third one is called standard form of the equation. That's on in Chapter 5, Section 5. So the first things, I need to give you some background here to try to make the whole picture fit for you. We need to discuss what the y-intercept is and some details about it and how it relates to standard form here, which you'll see in a few minutes. So x-intercept. Okay, let's talk about the x-intercept. The x-intercept, first of all, what is it? It's a point where the line crosses the x-axis. Okay, so if we have a grid, you can just draw a little grid in here. Okay, so we have our x-axis and our y-axis. And then we have a line, say, that goes through that coordinate plane. This point right here, that would be the x-intercept. Okay, right here, because that is the point crossing the x-axis, where the y-intercept would be up here. We've already talked about that. So let's look at some examples of what they could be. Let's say that that is the point 2, 0. That's one example of an x-intercept, 2, 0. Another example of a point of an x-intercept could be 3, 0 and 4, 0. And we could have values on to the left in the negative area, like -5, 0 is an x-intercept. -7, 0. And again, we could pick everything, anything on that. And the obvious thing here that you need to be aware of is the thing that they all have in common. And that is the fact that in all x-intercepts, okay, y is equal to 0. That's true of all x-intercepts. Now that's going to be important for us to remember. It is obvious here, as I stated, and I talked about it, and I showed you the examples, but you need to remember that on an x-intercept, the y value is 0 because the first value is x and the second value in an ordered pair is y. So y is always 0 on an x-intercept. Okay, hold on to that thought. Let's break these notes up. So put a boundary here. And let's move on down the page. I'm going to make this shade go away now and slide down a little bit here. And let's talk about y-intercept. Well, some things we already know about the y-intercept. We can find it in slope-intercept form. If I was to draw another graph like I did up here and label points, okay, what I know is basically it's any point on the y-axis. That I know is true of the y-intercept. So examples, okay, well, if I were to plot the point, say 0, 1, that would be on that would be a y-intercept because it's on the y-axis. It might be, I'm looking up here at this grid, it could be like right there. Another example could be 0, 2. Another example, I'll do some negatives. You can have 0, -5, 0, -1,000. Doesn't matter. The one thing that they have in common is that x is equal to 0 in any y-intercept. Okay, so x equals 0 for all y-intercepts. Okay, now you need to know that. You need to be aware of this. Okay, So with that said, I'm going to do another border here. So if we make a quick observation, for an x-intercept, it's the other value. It's the y that's 0. For a y-intercept, it's the x that's equal to 0. Okay, because we're going to be plugging that value in here pretty soon in standard form, which will lead us to the point of standard form. Well, let's talk about what is it. Okay, what is standard form? I'll add the words, what is standard form of an equation? Okay, so you want to get that down. You can find this on page 322 in your book. What is standard form of an equation? All right, I'm just going to give it to you here first. Here it is, capital A times x plus capital B times y is equal to C. All right, just write it down like that. Ax plus by is equal to C. Ax plus by equals C. Use capital letters here because that's traditionally what we've done. And let's talk about what these numbers are. Okay. Well, first of all, A and B and C. I guess I should say A, B, and C. So I'll make that a little easier for you. Sorry about that. A, B, and C are integers. Okay, that's required. If it's not an integer, it's not in standard form. Okay, so integers, positive or negative whole numbers. No fractions, no decimals for A, B, and C. They have to be an integer. Okay, here's another thing you need to be aware of, that A and B are on the same side. Of the equal sign. All right, C is alone. C is isolated. Now another observation is that A is the coefficient of x. So A is the coefficient of x. Whoops. Two F's. Coefficient of x. And B is the coefficient of y. Okay, so it's assumed that if I refer to A in standard form, I'm talking about the number that's being multiplied by the x variable. All right, here's one other thing, is that A and B, fill this in, this is important, A and B cannot both be 0. A and B cannot both be 0. Okay, then one last thing I'm going to squeeze in here. Okay, but one of them can be. One can be 0. All right, so what that means is if the coefficient of x is 0, B would have to be a value. If A and B are both 0, you don't actually have anything because you'd have 0 times x and 0 times y. It would be nothing. So one of them can be 0, but not both of them. C can be 0 at any time. Okay, so that's the detail. So it has to be in this form for it to be in standard form. A, x, and by, they're on one side. Okay, and C is isolated. Okay, so let's talk about y standard form. And I think I'm going to start another video to get into that because I'm not going to have time here. So get all that information down. And when we come back, we will talk about why is standard form important to us, and we'll look at an example. Okay, so we'll be right back.